You know what? Let's do... Alright, because we're going to keep changing our bubble index, then we're just going to say while... Okay, so while our current bubble value, right, is less than unsorted list bubble index minus 1, we are going to bubble it. However, we now have to keep track of the fact that what if we got to the end, right? What if there's no index that is in front of us, right? We bubbled all the way to the top of the list. So we have to also be able to say that if bubble index is greater than 0, and. So here's where we're using two conditions to control whether or not we execute our while loop. And this line just got long again, but I mean, it all fits within 80 lines, so it's fine. So 2 ampersands is logical and. So this entire statement is only true if both this statement, bubble index is greater than 0, and, or I'm sorry, yeah, bubble index is greater than 0. So we're somewhere out here, right? We're not at the very beginning of the list, because remember that we skipped the beginning of the list when we started our sort index, right? Because there wasn't any work to do, and the same thing is going to happen here. And I said, you know, is greater than 0. You could have said is greater than or equal to 1. And while it may look funny, you can also say if 0 is less than bubble index. So this is helpful in the cases where it is possible to make changes to values that are involved. Because sometimes we're looking at equivalency. Now here we're not. We're doing a comparison, but if we were looking for an exact value and we accidentally just typed an equals sign here, we could actually assign a value to bubble index. There's nothing that actually stops us from doing that. It's not a Boolean expression if we do that, but what would happen is, it's a little confusing, but any number other than 0 in a while loop or a for loop is actually true. And that sounds a little wonky, and it kind of is, but just be mindful that if you assigned a value, if this is just 1 or -1 or something, it's not 0, and it will actually evaluate to true. So by putting the 0 first, it becomes impossible for us to accidentally assign bubble index to 0 because that's not possible, because 0 isn't a variable, it's just an int literal. So it looks a little weird, but it's a great habit when you're comparing a variable to a literal value, to put the literal value first, so that way you can't accidentally assign to it if you were looking for comparison. So anyway, while 0 is less than our bubble index and the bubble value is less than the value of the next index, then we're going to do that whole swapping thing, right? So let's go ahead and say, so here we're going to just have a little, we're going to use, see how far we're going to bubble up through the list. So here we're just kind of mirroring like the pseudocode that we started writing before we had any real code. So if the bubble's lighter, so that's really like what this is doing, right? So if that bubble's lighter, and we're also making sure that we're not at the very front of the list. And then this other stuff, right, bubbles up, swaps the place. Now all this stuff, we can just kind of cut and say, this is what we would do next. And it's fine, we can have as much commentary in here as we want. It might look ugly for right now, and we can clean it up as we go. But this, we've already kind of captured what we needed to do in pseudocode, and now we can, figure out what we want to actually write code with, or how we want to implement these steps. And like you saw, I changed where things were. I might change a name. I might change where it's at, and that's fine. So putting this here now just kind of says, it's like placeholders for things to do, and we can just modify it as we go. If we find that when we start writing stuff out, we go, oh wait, I think I need a new variable, or oh, it makes more sense if I put this outside of the while loop and something happens, inside of my for. It's totally fine. It's why we write some pseudocode. It's just a placeholder. It helps you keep track of what's going on. It's also great for, that you need to do something, and it's actually a complex action that you might put into another method to keep this method simpler. What you're doing for your assignment isn't really that complex, but it's a great placeholder for, hey, do some really complex thing here. So if we bubble up, we're going to swap. So we need to, all right, so we don't have anything that's going to hold our swap yet, right? So so let's, outside in our for loop, we're going to have a new int, and this is just the swap space. And we don't have anything to put into it when it's out here in the for loop, so we're just going to create it, right? And I did move my comment around. That's fine. We'll just move that down here, and then we'll just say holds heavier bubbles to swap with current bubble. And again, you might be like, what? That doesn't make any sense, or that sounds silly. It's your pseudocode. It can say whatever you want it to say. It's whatever is going to help you mentally track what's going on in your code. Other people should be able to read it, and that if you put comments in your code, it'd be great if I understand what they mean. But you can go back and make things read better. Ideally, these things are in fact sentences, and they follow grammar just to help out other people that would be evaluating your code. For the class, don't worry about it, because I don't need to maintain your code. It's not like 2 years later we're going to come back and try to figure out how your code worked to make changes to it. But if you were in like a development situation, or even if you're writing a program for your own funsies that you might want to use months down the line, and maybe you're going to update it and make changes to it, add on to it, you're going to be doing yourself a favor to write really good documentation for what you were thinking this variable was supposed to do, because when you come back to it 2-3 months later, you won't remember. Like your short-term memory will have totally eradicated whatever these variables were for and whatever this while loop was about. So you can keep going and have so we need to make sure not at front of list, and next value is smaller. So anyway, so now we have a swap space. So I need to say that my swap space, whoops, I have to spell it right, otherwise it won't compile, equals unsorted list bubble index -1. Now you'll notice that just now I've done this. I've written the same code twice. So this would mean that if for some reason I later said, oh snap, that wasn't actually correct, that didn't give me the value that I wanted, or if maybe for some reason you wanted to swap the direction that you're sorted, that you were sorting the list in, and this isn't a minus and now it's a plus. If you do this, you're going to have to make note of it and come down here and change this code in both places to make it consistent and make it work. So this is a good opportunity to actually create another variable, and just says next bubble equals unsorted list bubble index minus 1. And actually that can't go here because, let's see, bubble unsorted, no, okay. Yeah, we definitely make sure that we set bubble index up here. That's fine. And just if we didn't have that yet, then, well, no, we probably should do that in next bubble. We have next bubble. Okay, that's actually a little bit of a problem because we need to evaluate that we are, yeah, because we have no guarantees here that bubble index minus 1 doesn't go off the end of the array. So if we try to access it, right, if we were already at 0, then this is going to break things. However, we know when we start, and see, this is where writing code, gets trickier, and it's good to have some visual as to what's going on, extra stuff to help you think. Draw pictures. I've got some diagram program that I'm using here to just keep things really clean and easy to see. But if you were using like a whiteboard where you could erase stuff really fast and move things around and draw lines, it's going to help you mentally keep track of what's going on. I could actually do some of that here, and I may do that in a minute. I can create some arrows that move in between things. And just by default, they're straight, and that doesn't work too well for us right now, so I'll just delete that. For the future. So anyway, we need to make sure that using this right here is safe. We don't want to be off the end of the list. So by default, we're going to start at 1, so even if we ask this, it's going to be 0, and that's okay. We just want to make sure that we never come back here when, okay, we can't. We're cool. And what we're going to see is, so because we did this here, outside of our while loop, even if we're changing bubble index, which we will be, at the point that we come back out of the while loop and come into the for loop, bubble index gets set to sort index, and sort index goes up. So it's never ever going to be the case that we're going to come down here and bubble index minus 1 is going to be -1, because we always start at 1. So we're cool, and while, yeah, it was a great place to go, oh man, what happens with our index right here? We actually turn out to be safe. But if there were some possibility that this could have gone negative, we would have needed to have done something else up here to make sure that we either were guaranteeing at the end of our loop that this value would never go to negative, or maybe wrap this in some kind of if, and anyway, we're cool for now, but it's just important to keep track of stuff like that. So now we have next bubble, so we don't need to be repeating this code. So what this means is, if for whatever reason we were to change this logic, right? So like I said, if we wanted to model our bubble sort more like a stone sort, and the heavier numbers are going to go towards the end of the list, we only have to change what next bubble looks like once, and then it's going to be utilized the same way later in the code. We only had to change it at one point. If we made this a plus, then we would be looking at changing our logic, and we would invert this. So we'd be looking if the current bubble, or in that case like a stone, is greater than the next bubble, it would fall through. It's just a great place to say, hey, I'm writing the same code more than once. Maybe I should create a variable to keep track of that, so I only have to change it in one place. Okay, so, and that's no longer part of it. So swap space equals next bubble. And then we're going to next. Oh. All right. Yeah, actually that wasn't as helpful as I thought it might be. And that's only because we keep having to decrement, but it's okay. It's all right. We'll just kind of run with it to keep on trucking along here. So we still have unsorted list. Now it could be that we just take the index, right? We just take bubble index -1, and that's what we save. That's fine. I'm just going to keep going for right now, though. Unsorted list, bubble index -1. Now gets, so we're assigning bubble, right? Because we've already ripped bubble out, and that's fine. So now, so our next bubble, right, whatever was in front, has been safely saved. We're going to move our bubble into the next index in our unsorted list. And now we need to move our list bubble gets swap space. All right, so copy the bubble into swap, copy the bubble into the next index, copy the bubble from the swap into the index, and decrement our bubble index. So while bubble index, so bubble index, and then just like we had plus plus for incrementing, we have minus minus for decrementing. So all 4 of our proposed steps have been accounted for. So we could keep these, but I think right now we can get rid of them just to save some screen real estate, so we're not looking at quite so much. So we're still just kind of keeping mental track of what we're doing. So then this would swap, and this is all we need to do, right? This is our individual action of saying, when this was, before. Well, actually, if we modeled it, 34 would swap with 42, but then we would stop, right? So we would pop out because bubble is no longer smaller than next bubble. So we would pop out. We come up here, change our sort index, change our bubble index, and then we're going to go, and then we're going to do this thing. You know what? I think. I delete all this stuff down here. Oh, that's right. Let's see, bubbling's false. Okay, so we've actually, yeah, that bubbling thing is fixed. Iterate over entire list except first index, while we're going to bubble. You know what? I think we might have a working algorithm. So let me hit compile and just see if I made any problems. Yep, forgot a semicolon. Whoops, and that is not a semicolon. There we go. Hit compile. Oh no, what have I done? Bubble index is already defined. Okay, that's cool. So then all I have to do is remove the type. So just a simple mistake. All right, now it compiles. Woot. So the way that I'm going to test this is I've already written some code up here, and this is a good practice. Like when you go to write an algorithm, now I'm going to give you a tester already. You're not going to have to worry about that. You don't have to worry about assigning your list or anything to search through. So I'm going to write a little tester up here that you can just call. And that's what I'm going to do now. This is like our top level tester, right? We're going to create a new integer list, and I'm using the syntactic sugar to define everything that would be inside of here. So I don't have to tell it how big to be, because this also tells it how big to be. And it actually maps to the original set of numbers that we had up here in our list. And then I'm going to print out this list so we can see our unsorted list. And then we're going to pass this list as an argument to our bubble sort algorithm. So we then sort the list, and then we're going to print it out again. So this method here, because arrays do not print easily, you might remember this from the code breakdown, but I create a new string builder, which I called scribe. And we use a for loop to iterate over all the elements in the array, and it just takes the value from each index, appends it to the scribe, the scribe just builds a string. So if you think about just writing it out on paper, it would write whatever the first value is, and then it would also append after that a comma. So we're just going to separate it by a comma. And all we're doing here is just making sure that we're not at the last value, because then we don't need a comma. If we wrote one, it wouldn't hurt anything. It would just kind of look silly in our printout. And then it returns the scribe as a string. So the string that we were progressively building together, we're then just going to spit that string back out, because system out print line needs something like a string. And we have an extra space here. I'll just take that out. It's not really convention. It looks silly because there's no space on the other side. So anyway, I think, let's compile again. Yeah, everything works. So let's test it and see what happens. So we're going to test bubble sort. Whoa, array out of bounds. Okay, so something is wrong. So unsorted list bubble equals swap space. Oh man, okay, see right there. Bubble index. All right, there we go. That's a problem. So, and let's just kind of clear that out so it looks pretty when hopefully it works next time. I didn't need to do that. And then, all right, test bubble sort. Oh man, okay. So something totally didn't work. Yeah, we just like obliterated everything and wrote 42s over all sorts of stuff. So it looks like, what did we do? How come 42 ended up everywhere? Where was 42 in the list to begin with? Okay, so we have 42 here, and then how do we have 42 forever and ever and ever and ever? It just seems really weird. Okay, it looks like our bubble value wasn't getting reset or something. Why would it? And see, this is perfectly acceptable. Like, I haven't actually done bubble sort before, so we're kind of, sort of, in a similar boat in that you haven't done a binary search before. So when you run something and you get something that you didn't expect, we just have to work it out. So Okay, let's see. We can figure out what's gone wrong. So 41 ended up at the front of the list, which doesn't make any sense at all. So it sounds like something in the comparison was wrong, and then 42 was getting passed and passed and passed and passed. So maybe something didn't decrement correctly. That's really weird. So it's almost like it's working the wrong direction. Okay, so where do we... Oh. Well, no. Decrement the bubble index. So, okay. So the bubble index goes down. If bubble is less than next bubble equals unsorted bubble index minus 1. So bubble index is always sort index. Sort index is always going up. Bubble index changes the once, right, which it should, and then it decrements after that. So swap space is next bubble. Oh. Okay. Let's do that. So, my choice there of how I was breaking that out wasn't, I think that might have been part of the problem. I don't think that it seemed to be holding on to one value the whole time. I think that was part of the issue. So this is unsorted list, next index, right? So next index equals, oh wait, what am I doing? Bubble index minus 1, right? We're going to subtract 1 from it every time. We're just not doing it in here. So the bubble is less than the next bubble's value, and while 0 is less than bubble index. Right, okay. Yeah, I think that's fine. Otherwise we would run off the array somewhere, like we did before. So swap space, unsorted list, next index, and then unsorted list, next index equals our current bubble's value. Unsorted list bubble index gets what's in the swap space. Right, and then the bubble index comes down. Okay. I'm not convinced that I've fixed anything. I've just moved a little stuff around, but it could be a subtle distinction that is easy to not notice. Well, yeah, okay. Wait, what's up with that? 12, 10, 34, 14, 17, 41, 42. Okay, so it almost kind of worked. It worked a little more. It just didn't go far enough. So it started sorting things, but each thing only moved one time. Okay, so then this while loop is only happening once per movement of a bubble. Okay, so why? So bubble index equals sort index. Sort index is always going up every time we go back over the list. So, right, and we know that it's going up because it's moving different numbers. If it didn't do that, it wouldn't. Okay, equals the sort index. The bubble is the unsorted list, bubble index. That's fine. We create our swap space. The next index is the bubble index minus 1. Oh, because that's only getting set once. Right. Okay, and the bubble index. So I'm trying to think. Right, so we have to have a next index out here. I guess just, yeah, I mean, one changes, the other one changes. All right. Well, that's a little, yeah, it's just based on, so since we're using next index here inside of the Boolean expression that controls the while loop, this variable has to exist out here. There's no way that it can't. But remember, like I said in the previous video, and apparently subsequently forgot, you know, this for the, you know, we did change bubble index, right? We were changing bubble index, so we prevented this loop from going forever. But because we didn't have something that worked with all of the changing variables inside the while loop, you know, a necessary change was happening, but then another necessary change was not happening. Okay, so now I think it will work. Test sort 10, 12, 14, 17, 30, 43. Woo! Okay, and you know, there we have it. So that's working through from a conceptual, hey, here's kind of how an algorithm works and a picture of it. Again, like if you have something like a whiteboard, it's a little easier for you to move stuff around and make changes and have it be obvious like where you were at. I just didn't have that really set up for this, and I'll you know, work on better things like that for the future. And then, you know, we kind of stepped through what kind of pseudocode I was writing, what variables I thought I needed, where I thought I needed to put stuff, making some mistakes, moving some stuff around, and then trying it again, and voila. So yeah, that's, I mean, like, that's coding, like right there.